All right, we're going to move on to the next lab now, which is module 2, lab 3. And this is kind of a fun one. So this one we call generation determiner. I'm going to do a little bit of file management here, as I've been doing kind of routinely. All my module 2 labs are here, so everything's going to get stored in here. Back in Visual Studio, making sure I'm in the lab folder, I'm going to create a new file. And this time I'm doing it from the sidebar, and I'm going to call it mod 2 lab 3.py. First thing we're going to do is, as we've kind of been doing, is look at some of the things that we need as a basis for the information that we're building. The overall goal of this program is as follows. We're going to create a function that tells a user what generation they are based on their birth year. And yeah, I already know which one I fall into, and it might shock you guys. I'm that old, but yeah, I'm that kind of old, which is pretty sad. I don't feel that kind of old. I feel more like a Gen X, I think, than a boomer that I am, but I am technically a boomer. They once again point to the information about functions, back to conditional statements or selection statements, else ifs, those. And then they also point to the logical operators here. So let's just kind of review those really quick. And I think this is really pretty important because we're going to be operating in a very specific area here, and that's why we need to look at this for a moment. Python does have a variety of different operators, and they go beyond math, they go beyond the assignment operator or comparison operators, but we also have logical operators and a few other ones, and we're not quite ready for the other ones yet. But the main focus here is the logical operators, but I kind of want to go through the stream of this because it's reinforcement. So first we look at our math operators. Okay, so we just had a little bit of run through with this. So addition, subtraction, multiplication, division. Modulus, which we just did, this is a remainder division. Floor division, which gives us just what, the whole number response without the remainder, and then exponents. So we reinforced those pretty well this session. We also have assignment operators. Now we think typically of the assignment operators just the equal sign, right? Like thing on the right will get stored in the thing on the left, right? So it's not really an equal sign. But we also have these other ones, which are kind of interesting. And I'm really going to kind of not cover these because these get kind of deep, real frankly. But these two are really important, the plus equals and the minus equals. And so the grand point of this is that if I had an equation like where I take the number I already have and add a value to it, I can also use a shorthand notation in Python, which I just call it plus equals, right? Which basically adds 3 back to the value and puts it here. So functionally, this statement is equivalent to this statement. And most experienced programmers, by the way, go to this. If you've already coded before, you know what I'm talking about. C#, Java, JavaScript, you do that in all those languages. Experienced programmers go to the highlighted one immediately. Now, in addition to adding things, you can also subtract things, right? Those are the two that are most typically used. We increment values, or we decrement or we reduce value. You can use the other mathematical operators though, but I'm going to tell you what, these get more challenging. Multiplication and division, maybe not quite so hard to conceptualize. When you start to get the mod and floor division, those are, I've rarely used these in coding, but there are those situations, right? You can do exponents. Oh my God, you can, yeah. So it goes on. I'm going to leave these alone because these are really complicated. And mathematically, even from a conceptual philosophical standpoint, they're kind of complicated to comprehend. So I'm going to say functionally, don't worry about any of these. Well, any of the ones below these, maybe these on occasion, but these are the two that you'll use the most. And of course, the equal sign you'll use all the time. Right, so those are the assignment operators. We also have the comparison operators. We started to use these with the if statements a little bit, right? We didn't do a lot of it, but a little bit, right? So we're going to be ramping this up a little bit now. So these are always used, and just so you have the name on the screen, comparison operators, when often we're doing Boolean tests. We're testing something for true and false to decide whether we're running a piece of code or not. And so equal tests equivalency. Does X equal Y is really what this means. And the result of it is true or false. In fact, if you use the triad editors on this, you'll see, for example, 5, does that equal 3? The result is false. Interesting, right? And that's the actual output, false with a capital F, true with a capital T. So if I change this to 5, does X equals Y? True, it does. Right. And the way I like to refer to this is equivalent to, so I'm not like confusing it with this one. This is an assignment operator. This is a test of equivalency. So going back to this then, we also have the not equal. All right, just to demonstrate, does 5 not equal 3? You know, X is 5, Y is 3. Well, that's true. All right. Does X and Y being equal, does X not equal Y? Well, false. Because X does equal Y. You know, X is equivalent to Y. So saying that X is not equivalent to Y is false. You see, right? So there's times where this negation, that's what you use the exclamation point in front of it. Interestingly, that symbol can also be used in front of other statements to negate its meaning. So if a whole statement is true and it's inside of parentheses or something, you can put an exclamation in front of it to negate the concept. Okay, so don't freak out to that, but it gets a little heady, you know, at times, so it's easy to screw up too. Of course, we have standard greater than or less than, greater than or equal to, less than or equal to. Remember, unlike math, the equal sign follows rather than being a single slash underneath. But now we get to the logical operators. And these are based, once again, on the branch of math called logic and set theory, basically, where we do look at these concepts because sometimes we have more than one condition we want to check for truth before we execute a piece of code. So for example, if I need X to be less than 5 and X to be less than 10, and I need both of those to be true, we use the keyword of and. So in other words, in order for the whole statement to be true, both parts of it must be true. This must be true, and that must be true. And this one really is a good idea to test it. Now we're using one variable here. And so is X greater than 3? Yes. And is X less than 10? That's true, right? But what if I change this value to 5? Is X greater than 5 and X less than 10? Think about it for a second. See if you can get it faster than the computer. False. Because it's not greater than 5. It is 5. If I wanted this to be true, I could change this to say greater than or equal to 5. Now, both sides of that statement are true. So the whole statement is true. So that's kind of thing. With an and, both must be true. Now, when we use the keyword or, then what happens is only one of the statement needs to be true for the whole statement to be true. And let's go try that one. Here, X is 5. So the first statement is true. So the result is true. Is X less than 4? No. What if I change this value to is X greater than 5? Now, both statements are what? False. So it's false. But what if I change this value to 10? So is X greater than 5? False. Is X less than 10? That's true. Only one of them needs to be true here for the statement to be true. So I get the result of true. All right, so hopefully that helps to explain it a little bit. And then we can also use not. So we have a combination statement that might resolve the true or false. And we're looking for the opposite of it. And by the way, you can also use the exclamation point here too, but I think they prefer you to use not. Right. This is a weird one. I try to stay away from it because it's like you're already using a combination logic here. Chances are you could reword the syntax to make it do the same thing and not use the not. But if you have no circumstance in which to do that, then you revert to the not. And or, very commonly used. And why do you use this? To simplify the number, or I should say minimize the number of if statements that you're checking or else if statements that you're checking as you go. Right. So you don't like go too far down the logic. The other aspect of this is you don't have to limit yourself to 2. So I could say X is less than 5 and X is less than 10, and X is greater than or equal to Z or whatever. I could chain a whole bunch of those. And if I keep using the keyword and, all of them still must be true. And I can also do the same with ors. So I could have like 5 ors, and only one of the 5 needs to be true for the thing to trigger. Right. Now the setup, once again, when do you use it? My favorite answer, it depends. Depends on the situation. And the situation dictates the logic. So the real world situation that you're trying to solve dictates the logic for how you put this together. A really great example, like if you guys are like doing your taxes at this point, right? It's like if your income is greater than this much, but less than this much, that's a classic setup, greater than 20,000, but less than 50,000, or over 100,000 and less than 200, and both of those things have to be true. And what it's really doing is it's narrowing you to a range. So that's often what it's used for. And doesn't that sound kind of familiar? Because if we're trying to figure out what generation you belong to, we're going to try to narrow you to a range based on age or the year you're born, and figure out if you truly fall into that range, true or false. So you can use it to identify whether you're inside of a range or if you're outside of a range as well. And often the trick to that one is flipping the greater than or less than signs as you're doing it. All right. Let's look at the breakdown of the problem now and see if we can start solving it. If you're wondering, yes, we're going to do another break shortly. All right, so enough lecture-y stuff there. All right, so here's the breakdown. Create a get generation function. It accepts no parameters. It returns a string with the name of the generation. So it'll say alpha, Gen Z, millennial, Gen X, baby boomer, or wow. And thank God I don't fit into wow. I fit into boomer. Yeah, I think my parents would be wows because, oh, wow, those people are still alive. Yeah, some of those people actually are still alive. Right, call the function and print the return value 3 times. So you're going to prompt the user, what year were you born? They'll type in a value, and then I'll say millennial, et cetera, et cetera, et cetera. And yeah, that does unfortunately happen to be the year of my birth. So I am a boomer, the very tail end of it. But I like to think of myself as more of a Gen X mindset, maybe even a millennial mindset, because a lot of people who are boomers don't like technology, and they really necessarily don't embrace it as much as I do. I think I'm one of those cutting edge boomers. And they do make a note here, use logical operators. All right, so let's get to coding this. And I think there might be maybe a little bit of value to maybe experimenting a little bit before we write the actual program. So I'm just going to do a couple things. I don't know. Actually, I'm gonna waffle on that a little bit because I think I just did the experimenting on W3 schools, right? I think that was probably a good enough demo rather than doing it in the code. So I'm going to get right to um, writing the actual code. And I think what you guys are going to find is that the logic on this actually goes really, really fast. And you'll see why. All right, here we are doing lab number 3. And we were told to create a function called print generation. And what are we going to feed into it? We're going to pass into it the year the person was born. Also, I know I'm going to like write some code here, so I'm just putting in a placeholder right now, but I'm going to come down here and I'm going to remember to call it. In fact, I'm going to prompt to call it. So I'm going to do it like this. In fact, I have the statement ready. And I think I'm locked up here. You guys are locked up in my Zoom session. Can you guys still hear me?
Yeah, I can hear you.
Okay.
Yeah, I can still hear you.
Yeah, Zoom totally freaked out, by the way. It was completely locked up. It locked up my entire screen. And you know what? I'm going to blame W3 Schools. I'm going to free up a little RAM here by just closing all these silly tabs. Unfortunately, these days, Chrome has become a pretty good memory hound, or hog, I should say, not hound. I've also got a couple things here in the background I could probably close. I have Spider running, and I have my snipping tool running, and my settings are open, and this, whatever that is. All right, just freeing up RAM, just a strategy. I could also turn on my turbo boost fan, but I'm not going to do that right now. All right, let's go back here, and I'm just going to prepare my prompt in advance. And here it comes. So it's just ready to type it in. So I'm just going to have them enter a year. We're going to convert it to an integer. We don't need a floating point on this. Then it's going to send it to the function. And then the function is going to take care of figuring it out and printing it to the screen. All right, so here's the code. We'll start at least. So the first problem you have to identify here is we have a range we're working with. So you could write this so many different ways. And I'm going to kind of just put it out there that introductory level programmers will tend to significantly overthink this, right? And even if you've been in our coding programs here at WCTC and you have experience in other languages and you've written if statements before and you've seen this compound logic, it might not necessarily appear readily evident to you what the most efficient way is. And I'm going to show you kind of a way to approach it, and then I'm going to revise it and make it more streamlined that will actually avoid all the logical operators, right? So if I was, for example, to type in, an age in this range, these are basically our children now, right? And like my children fall in this range. I'm hoping none of you are in this range. You're probably too young to be here if you're in this range, but there might be a few. And I'm going to guess that a majority of us are probably, probably in this range, but maybe in that range too. Right? Just a fair guess. So if I'm doing a range, how would I really pick? How would I say like you're part of the alpha generation? Well, I would say if your birth year was greater than 2013, so year greater than 2013, and year less than 2025, right? Or would it be greater than or less than or greater than or equal to or less than or equal to? Well, if I want to include those years, the equal to has to be in the mix. Okay, so let's go ahead and start writing it. So I'm going to say here in the function, I'm going to say, and I'll go in one click on Zoom here to make it easier to see. So I might say if year is greater than or equal to 2013 and year is less than or equal to, what was the cutoff? 2025. Hey, they haven't even been born yet. Right, so we should have nobody in that range, but okay, we're preparing for it. All right. And then all we're simply going to do is we're going to print what generation they are. We're just going to say alpha, maybe with a capital A. All right. Can we just try this much? I mean, this is really simplistic, but let's try it. So I'm going to type 2014. Okay, alpha looks good. Run it one more time, and I'm going to put in 2009. Okay, gave me nothing because I don't have a scenario for that, right? All right, so what I could do, all right, so you could handle that, of course, by saying else and have an else that says you part of any of generations. So let's try that again. Running it. We'll try one in range again, 2020, oops, 2022 alpha. And we'll try one out of range. And we'll say 1964. Okay, I haven't accounted for that generation yet, but you aren't part of any of these generations. So you can see this compound statement works. Absolutely works just fine. Now, of course, if I want to check another scenario, because what if, you know, it's less than 2025, but not greater than or equal to 2013, well, then I can create an else if. So I can go elif, right? Sorry, that's how we do it in Python. I'm going to indent, but I have to have a condition. Okay, so here's my condition. For the next generation, gosh, I don't remember this. Gen Z is 97 to 2012. I could kind of copy this syntax and just change the years, right? So greater than or equal to 1997 and less than or equal to, well, it has to be 2012, right? See how I didn't even remember that? That proves I'm a boomer, right? I forgot it from 2 seconds ago. And just wait, it'll happen to you too. Actually, I blame Google more than I blame my age because it feels like now that we have Google, we don't have to remember anything anymore, right? Kind of a weird thought. We call this generation Gen Z. All right, test it once again. So I'll type in 2000 Gen Z. Okay, it's working. Of course, I could test the outer ranges to make sure that they work. But now that you have the pattern, I think it's pretty easy to figure out. I think actually this is a good spot for a break. And what I might challenge you is if you want to keep working through the break, you could try to build the rest of the code on your own with the compound statements. All of them would be ands, by the way. So if you want to do that, I'm going to pause the recording and I'll see you guys in about 5 minutes. I will leave my screen share. Logic. So, all right, we're going to kick back into this now. And what I'm going to do is I'm going to take this info here, and this is really kind of goofy, right? But I'm going to actually bring it over to my screen, and I'm going to do the triple double quote thing and paste it in here just so I don't have to flip back and forth. So the dates are right there. Now we've already done these two, right? So I can delete those. Now I can just have these handy. So at this point, I'm going to repeat the else if, and I'm just going to tweak. So the next range is 81 to 96. And that is millennial. I'm going to paste again. Oops. Paste it because I buffer with something else. Copy it again, paste it again. Then we will do 65 to 80. And that's Gen X. And then we have one more to do here. And that's the boomers, present company included. And let's do it correctly here because we are baby boomers. That's back when people actually wanted to have children. And it's happened, by the way, the alpha range, and really, I think the alpha range started a little bit earlier, around 2008, when the economy faltered a little bit. People dramatically decided not to start having children, like the birth rate dropped significantly. All right. Maybe that's a good thing. Maybe it's a bad thing. I don't know. I'm not making any comments on that. And then if you're out of these ranges, it'll fall right through. So I'm going to go ahead and leave that up on the screen here, but I'm going to go ahead and run this. And let's try all the new ranges. So for example, I'm going to try 1984 as a millennial. Then I'm going to try 1972, which is a Gen Xer. And then I'll do like a 1954, which is a baby boomer. Singular would probably be better. And you know what? Maybe we can just call it boomer. It doesn't really matter. So one last thing we need to check again is maybe a value that's way below the range, like 1905. And maybe a value for a year that hasn't happened yet, like 2030. And so it's working, the logic is working for all the scenarios. All right. So this is a fine solution if you write it like this, because after all, we are talking about compound logical operators and or and not. So it kind of makes sense to use it. Now, here's where it gets a little weird. So I'm going to copy all this code, and then I'm going to show you why there's actually a more efficient logical way to do this. And this is, once again, one of those things you don't see initially as an introductory level programmer. You see this when you become more advanced. And so I'm going to leave all this code in place, and I'm going to use my triple double quotes here to turn it into a comment. And then I'm going to repeat the code below. Oops. Now I'm pasting the wrong damn thing. All right, let me copy all that and paste it back in. So we're going to re-engineer this, and I want to show you that what's fascinating about this is I can accomplish the same thing without a compound statement, and I'm going to show you why. And I'm going to ask you the question. Will this code also work correctly? And okay, so I have one person nodding your head, right? So yeah, so you've either already tried this or you have the experience of being a programmer and you understand why. So check this out, and I want you to think about this really carefully. If I type in, greater than or equal to 2013, now where this will fail, of course, is on this first one, because if it goes beyond the 2025, then they're not really alpha, but whatever, okay? So maybe this one could include the and. But let's say there's nobody up in that range anyhow, so nobody's going to type that in, so it's not even necessary, right? So you can't type 2030 if it hasn't happened yet, but you could type up through 2024, right? So this would work. Greater than or equal to 2013 would give you alpha. And then if I type in 2012, is that greater? Well, this would be false. It wouldn't catch this one. So it would skip this one and go to the next one. And then it would say, well, is 2012 greater than 1997? Yes, it is. So this would print. It'd skip all the others, right? And that's an important part of this too. So if one part of the if statement rings true, the rest don't process. So if the first one doesn't catch, and then the second one catches, all the rest of them will bypass. But for the same reason, this one works correctly following this one, all the subsequent ones work correctly too, only because I'm doing it in the order of greatest value to lowest, highest year to lowest year, and the logical check is greater than. If I would have built it from the bottom up and said less than or equal to 1964 and went the other direction, I could also make it work in the other direction. So you could actually string it two different ways, but notice that it eliminates one part of the processing. So instead of doing two logical checks, I'm doing one, which means my code will operate faster. This code is faster than that code. Now, we do live in this era now where computers are really fast. We have lots of storage. We have really fast processors and GPUs, and we have AI and all this crazy stuff. But it's still important to write efficient code. So either one of these approaches will work correctly, and I would take either one as the correct answer. Or if you really want to challenge, you want to challenge yourself, you could reorder this from, in other words, start with boomers, Gen Xers, and go the other way, flip the signs and use the other end of the range and re-engineer it. If I had time, I would do that for you, but we want to move on. So this is lab number 3. I'm going to move on to the next lab, folks. So we're moving on to lab number 4 here. Let's hit the next button here and just go over to it. So this one's called the Age Milestone Informer. Once again, reinforcing some of the stuff that we're looking at. So functions we've looked at, if-else statements, logical operators, those all come into play. And then we're going to look at the date time module. So let's just go over W3 schools yet and take a look. Now, if you've learned how to do coding in other languages, and I'm going to probably pick on C# because that's one that we teach here a lot at CTC. Where I teach over at Gateway, we are really heavy on Java. In our software program, we do C# and Java, right? And in our web program, although we're thinking about moving away from this, we teach 2 levels of Java for backend programming. But what we've discovered is backend programming has moved to many other different languages, most notably Node.js and C# and whatever. But the point is, in those strongly typed languages like C# and Java, date is a data type, just like an integer, a floating point value, or a string. And it's actually a data type. And you can create data in that format. Python doesn't have a data type for it, but does have a function named datetime that allows you to capture the date and store it as an item. You do have to do an import. So we haven't really done, I don't think we've done any of that yet. Maybe the random number generator, did we do that? I forget. But what this statement does is it imports a specific library of functions that's not normally part of the standard library because not everybody uses them all the time. And you don't want to pull the overhead of that library into your program unless you're using the tool, right? Because it adds a bunch of code to your code base. So first we have to import the library, and then we can, run this function, which basically goes, this is the library, this is the function, and then this is the when, right? Because you could, have parameters on this, but this pulls the current system time from your computer. It looks at your system clock and says, what time is it? Oh, there it is, right? And then it stores it here. So if you try this, so this is the kind of output you get. You get the date. Notice the format of the date. It's year, month, day, and then uses the 24-hour clock, hours, minutes, seconds, and well, this would be milliseconds. So it's thousandths, 10,000ths, 100,000ths of a second. That's how precise it is. And every time you run it, it will generate a U value. Right? Super, super precise. Right. So it gives you a timestamp. So like if you're running a piece of code and you want to track like when an event happened, this will give you the exact time. Now, the format of this is kind of interesting because when you're converting from a 24-hour clock to a whatever, one thing you'll notice is whatever server this is running on, you guys catching this? It's 2:23 in the morning wherever the server is located, which clearly is not central time zone. What time zone would that be? Yeah. What this actually
It
is.
sounds like UTC to me without checking.
Yeah, precisely, Cody. And so that's the universal time clock, which is located in Greenwich, England. So right now, when I hit the run button, it's pulling the UTC 0 point, which is, they came up with the standard time clock in Greenwich, England. So whatever time it is in Greenwich, England, that's the time right there. And then all the other times on planet Earth are either plus or minus that time, right? If you want to convert this to a format that's more friendly for you as a user, there's different formulas that we use. So like if you just want the date or you just want the time or you want the time in a standard 12-hour format instead of, AM, PM kind of thing, there's stipulations for all of those things. And they talk about that, right? And then they show you how to adjust it. So if you want to know what day it is, you can extract all of that from those functions. Right? I mean, I don't want to go too deep into that, but you can, for example, also generate it or just read it in either way. All right, so the first thing that we're going to do is we're going to import that into our program. Let's go back to Visual Studio Code and build the next lab here. So I'm going to create a new file. Let's do save as this time, and we're going to call it mod 2 lab 4 y. And we're going to start with the import date time. So now we have access to that special library. Create a get birth date function and get age function. And so you notice how I'm kind of like paraphrasing here almost. I know I need to create this, so I'm going to create the two functions right away and then put the code in. And that way I have the structures in place. So I'm going to define get birthday. I'm not sure if I need to pass anything in. I'll figure that out later. And I'll just put in some whatever. And then I will also define get age. Parentheses and a colon. And then also placeholder, right? And then somehow we're going to call these. I'm not sure yet. Okay, but the structure is there. The first one accepts no parameters, so we're good. But it gets the year, month, and day from the user and returns a date object based on the input. Okay, so all right, so let's see if we can get that to happen here. And you know what, you guys, I'm going to take a really quick pause. I have something going on in the house here I have to contend with really quick. So I'm going to pause just for a moment. Roll on this now. All right, here we go. All right, so let's first, and I just want to read the instructions here really again, so I'm clear on how they're doing it. So this one just prompts the user for 3 values. Okay, so I'm going to try to do this as efficiently as I can. And so I am, yes, copy pasting the stuff in. And notice the discrepancy in my indents, and you always want to keep those indents consistent. So we're enter the year, enter the month, enter the day. Now we're assuming numeric input here. So the year would be 4 digits, right? And so what you might want to do, and I'm just kind of putting it out there, right? You might want to go like this. Right? Month. And that could actually be one digit, right? And then the day. And I think it's helpful to let the user know that stuff. Then if you want to return this as a, it says returns a date object based on the input. We're just going to basically feed this information directly to date time. So instead of retrieving the time, we are setting the time, right? But just the year, the month, and the day, and in that order, right? So wherever we call this from, we're going to maybe set a variable called date, and then we're going to feed the stuff in. And just to kind of give you an example here, I could just run this as is, right? So I could set up a variable, and then I could just simply print that out. Yeah, it's expecting me to write something here. So I'm going to just write a blank print statement here so it doesn't error on me. All right. And you can see I called it something else in the past. So birth date. Right, so let's just run this so you can see what it does. Enter the year. Enter the month. Enter the day. Oh, and I got an error. And what's my error here? Time is not callable. Oh, okay. So I missed a little piece here. Right, so we have to add this to it. And I got to switch my terminology. So I apologize because we are looking for a very specific tool. And so we're going to do import from date time, import date time. And notice what I did here, why it didn't work. Right, so I think I can just do it like this. So okay, I feel really silly about that. All right, let's try that again. All right, enter the year. If it fails again, then I'll have to add the from statement. Okay. So I do have to have the from date time, import date time. Now let's try it one more time. I apologize for the fumbling here. 2021, 12, 25. All right, so there it is. So now I'm creating that object. Use it in our code. Everybody good so far? When examples go great. It's wonderful. When the examples don't, then it gets interesting. And then you have chaos in the household. That doesn't help. All right, so that's part one. And really, I guess I really don't need that blank line there, but that's a nice, concise little function. Now let's read the other instruction. We're going to have a get age function that accepts one parameter of a date object. This is kind of interesting. We're going to pass that whole thing over. We're going to compare the parameter against today's date and converts the time into an integer representing the age. All right, so this will be kind of interesting. So fumbling a little bit with the solution on this lab, and I've decided to basically rewrite this function after doing a little bit of research. And I found some information, of course, thank you, Google and the internet and Stack Overflow, where there was this kind of lengthy conversation here on Stack Overflow. And, you know, everybody's like got all these like really fancy ways to do it. And then ultimately somebody at the very bottom, of course, shows like a super simple approach, and I plugged this into my code and it worked, you know. So and basically what I'm going to do is I'm going to grab, you know, basically these pieces here and drop them into that function and make it work. I do have that actually over on another screen, so I'm going to pull that over. So I'm going to rebuild this. I the get birth date part, that creates that date object. And so I'm still calling that here. And then I'm going to, in this case, capture the time now. So I'll just call that now. And we'll say date time dot now, which we did before. We saw that it creates the same kind of date object. And then age will basically be equal to the now year minus the date year or whatever was entered in. And then we'll very simply return the age. And this is really kind of the magic trick, right? So there is an attribute. And we haven't really learned about objects yet, but objects basically carry complex data with them. And we call those properties when they're referred to with a dot syntax like that. So like embedded into the object is the year. And then if I subtract the one object's here from the other, I come up with a difference. It stores here and I just return it as a number. So when I run get age with the date object that was typed in manually, we do the comparison with the now time it stores here, and then it should come out correctly. So let's cross our fingers and give it a try. So here's the, let's put in 2010. And, you know, it doesn't, the day and the month really don't matter. But now we can see a 14-year difference. So now the code is working. All right. So that's actually part one of the solution. There's another part of the solution, which is to then make a determination of whether you're qualified to vote or not, which is very timely. I will save the recording of that for later because it is getting late tonight. But this is the two functions working at least. So I'm going to end this recording here. And then I plan to stitch them all together. So thank you all for hanging out and watching me figure it out. And watch for the solution soon. Hello, everybody. I'm continuing my video here on Module 2, Lab 4. We basically ran out of time last night. So as I kind of record this, I just kind of want to recap what we kind of figured out after most of the people left the session. I did have a few people that hung out and we troubleshooted this and figured out the correct code. Basically, you know, if you look at your Module 2, Lab 4, we were struggling with getting the right syntax to calculate the age. And the syntax actually worked out to be pretty simple. And I think maybe I've recorded this in the video that precedes this one. But what you see on the screen here is that first, that call to this function, get birth date, where we actually ask the person to enter the year, month, and day. Then we feed that into the date time function, which creates that as a date time object. Of course, we did originally just do an import of the date time library, but then we made it a little bit more specific, which allows us to streamline basically the syntax in the statements. We then built the get age function. And what we did here was we grabbed the current date time as an object. And then we took basically what we call a property or an attribute of the object that was created. So we take the year from the current point in time and then subtracted the year that the user entered to come up with an age. And then we return age back to the main program body and store it in a variable. So what we're about to do now is kind of complete the rest of the logic inside of Canvas to complete this lab assignment. So I'm just going to pull that up on the screen here. And basically, just to kind of review where we're at, we, in my mind, have completed this aspect and this aspect, and we got them working. So what's left to do next is to call the correct functions to get the user's age and output the following. And you can see here is kind of like the way that these bullets are structured. It's a little bit of a hint in terms of the logic that you want to use. So what we're trying to figure out, is the user old enough to drive, vote, and be president? And the first two of these kind of sit independently, right? So like, how old do you have to be to drive in Wisconsin? We have to be 16 or more. How old to vote? 18 or more. So those are two actual very simple little if statements that we can write. But the next one, in order to be president, becomes a little bit more complex because there's a few different requirements. And One is that you have to be above the age of 35. You have to be a natural born citizen. Um, and you have to have lived in the US as a resident, official resident of the US for at least 14 years. And then based on all those ifs, we can determine if the person is qualified or not to be president. And now, the first part of the exercise was actually a little bit difficult, but the second part is actually not that difficult. So I think that ultimately, when I do publish this video, I'm actually going to maybe just publish this last one. I'm not really sure. I might do some edits. So like if you guys get weird edits in the process of this, you'll understand why. I may include at least the build-up videos because I did talk about a lot of lecture stuff. So I know this is kind of redundant at this point if you're watching the videos, but hey, that's kind of how it goes. All right, so let's see if we can kind of tackle this logic. You know, this stuff is all done. Now we just have to engineer this part. And you know what? This part will be easy relative to what we just went through trying to fix this code. So we successfully grabbed and calculated the person's age. And I just want to demonstrate this once again. So if we run this, we put in the year, and really what we're doing is getting the birth date. And now that I'm looking at this, you know what? I'm going to cancel the run of this. So I just did a Control C to stop it. Enter the year of your birth. You know, because you know who's you don't really know which thing we're asking for here without that. So I think it's appropriate really to make sure we're asking for the right information. So, all right, just to kind of use my own information here, kind of drive this. And yeah, I'm not quite that old, but I'm close to that old, you know. So, you know, so I can say that maybe there's a little bit of a flaw in this because technically I'm still 59. So we might actually want to tweak that a little bit because we're not really taking into account the month and whatever. I could argue that maybe the smart thing to do is maybe we could kind of omit that, but we were asked to put this in, right? There would be code where you can use to correct it for the month and day, but I'm not going to worry about that right now. Let's just go with that being fairly correct. As ugly as that number is for me, right? So don't worry, someday you'll get there too. So it is working and it is returning the correct age. So what I'm going to do here then is I'm just, instead of doing, you know, print age, I'm going to do print, and I'll do a printf on this, and I'll say you are about. Actually, let's just pretend like it's precise. You are age years old. So that's just a statement. I'm also going to put in a blank line here. All right, so now we need to kind of start asking the questions, right? So if you have calculated that somebody is of a certain age, well, let's run an if statement here to see if they qualify to drive. So the if statement would be pretty simple. If the age is greater than or equal to 16, then we can just say qualified to get a driver's license, or however you want to word it. But basically, the person can drive. If you want to say you can drive, yeah, that would be fine. Next, we're asked to determine if the person can vote. Is that part of the same if statement? No, it's not. This is a separate standalone if. So, you know, think of it as a discrete if or whatever you want to put it in your head. And the syntax is very, very similar here. So we're going to say, if your age is greater than 18, you can say print, you are eligible to vote. Let's register, right? And so that's a important aspect of that. So you can't just go show up at the polls and vote. You have to like prove that you're registerable, and then you can register. And ironically, today is a voting day, April 2nd, 2024, as I record this video, and I have to remember to go do that because there are some important referendums on the table this time, especially here in the city of Milwaukee. All right, so we got the first two pieces out of the way, but I do want to talk about another concept here that we haven't really mentioned yet. And, we're starting to talk about Boolean values. And by the way, Boolean values are basically either true or false. And so basically a Boolean value is something that resolves to one or the other. Why is it called Boolean? Because some guy named Boole came up with this concept. And so they're Boolean values as a result of that. I do want you to notice in Python, when we use the values of true or false, we do use a capital letter at the beginning of it. Some languages don't do that. Some languages do. But when you create something as a Boolean value, that's how you must designate it. Now, the other thing I want to talk about is sometimes when we write software and we want to determine if something is true or false. So for example, we're working towards determining if a person would qualify to be president. I don't want to pre-qualify them to be president. I want to, set a flag that says by default you're not qualified. First, we have to ask you some questions, and then based on those questions, then we can determine if you are or are not. One of the questions is age, but this next little piece of information, this item below is a flag, which we often insert Boolean values into. So for example, I'm going to create a flag called is qualified, right? And you see how I'm naming it with a camel case. And I'm going to preset this to false. So I don't want to pre-qualify somebody to be president. We're just going to assume you're not qualified. Then we'll ask you the question, and then we'll see if you're qualified. All right, so we'll start with the first question, which is, if your age is greater than or equal to 35, that's the first hurdle. Okay. And then we're going to prompt them. And okay, so if you clear that, then I can ask you the next question, Liz, which is, are you a natural born citizen of the United States? So I'm going to set a variable called natural born, and I'm going to ask by an input statement or a prompt, are you a natural born citizen of the US? And then, and really what I'm looking for is yes or no. So I want them to type a Y or an N. All right, so that's the prompt. So we'll capture that little piece of information. Now, based upon that input, we can ask the question. So we have to do another if statement here. And here's our kind of one of our first examples of what we call a nested if. So maybe it's appropriate to label that. And so if the first statement rings true, we prompt them. Now we'll ask another question, but it's inside the other. So this will never get asked if they don't clear the hurdle of 35. Okay. How deep can you nest your if statements? As deep as your mind can take you, basically. There is no limit on that as far as I know. And most people rarely go beyond 2 or 3 or 4 levels of it, but you can go pretty deep. I have seen some code examples that go very, very deep. All right, so now I'm going to pull in this natural born thing, and I'm going to ask the question, if natural born is equivalent to Y, and you know what, we could run the function to lowercase this. I'm not going to worry about that right now, but if you wanted to really make it appropriate, correct, that's what we do. So if they say, yes, they are a natural born citizen, okay, now I can ask them the next question, right? So this if is inside that if. So now we're 3 layers deep. And now we're going to prompt them. So we're going to have them prompt. And notice how this is going right in the if statement. And what I'm going to say here is, I'm trying to think of good terminology, because basically the prompt needs to be, have you lived in the US for at least 14 years? And maybe it would be asked like this: have you been a resident of the US for at least 14 years? So the question mark, and then once again, we'll do yes, no, and space there at the end. Right. So now if this statement resolves to be equivalent to a lowercase y, then they passed this hurdle, they passed that hurdle, now they're passing a third hurdle. Then we're going to flip this flag is qualified. And in fact, I'll just copy this part of it. We're going to flip that flag to true. And we're going to use that true statement to trigger another if statement. So our if statements end here. Right? So an if inside an if inside an if. Right? Then we're going to pop back out to the margin here. So let's come down a line back over to the margin. So now we're outside that if structure, nested if structure. Now we're just going to say if, now watch this, is qualified. And I'm not going to say anything else. I don't need to say anything else. This is a boolean. So it either is true or false. And then we will just simply print out a message saying, print, you are qualified to run for US president. If they're not, if the condition is false, we'll just have an else. And we'll say, I guess basically the converse of that. You are, maybe emphasize it, not qualified to run. We could maybe, I mean, if you really wanted to get detailed about this, you could tell them why, if you wanted. But I'm not really concerned with that. This would basically solve the logic correctly. So let's go ahead and run it and see what happens. Here goes. So Control S to save. Here's the run. Put in my boomer info here. All right, so you are 60 years old. You are qualified to get a driver's license. You are eligible to vote, but you must register. Are you a natural born citizen of the US? And I'm going to type in yes. Have you been a resident for at least 14 years? Yes. And it says you are qualified to run for president, and we are all done. So that's the solution, folks, for lab number 4. I'm going to end this video here, and then I will get this published so you guys can get working on this. So this video ends here.